Hi, welcome to my channel. Basically, the mathematics needed in quantity surveying is geometry and trigonometry. Geometry plays a vital role in the construction process. Here, we will discuss the 2D and 3D shapes commonly used in quantity surveying. If we know the formulas of all these geometrical figures, it will help us in the calculation of quantities. Let us see how to calculate the area, perimeter and volume of different geometrical figures. We will take the 2D shapes first. Here the first one is a rectangle. For a rectangle of length L and breadth B, the area is length into breadth and perimeter is 2 times sum of length and breadth. For a square of side A, perimeter will be 4 times A and area will be A square. We know the sides of a square is all the sides are equal. Next is circle. For a circle, the radius is diameter divided by 2. Here D is the diameter and R is the radius of the circle. For this, we will calculate area as pi into R square or pi D square divided by 4. Perimeter as 2 pi R. For a semicircle, perimeter is equal to pi into R plus D or pi plus 2 into R. Area is equal to half of pi R square. That is half of the circle is semicircle. Next is quarter circle. Quarter means 1/4. Here, for this 1/4 portion of the circle, area will be 1/4 of the pi R square and perimeter will be half of pi R into pi R plus 2 times radius. This is a right angled triangle. For this triangle, base is B and height h and hypotenuse is L. For this triangle, we know as per the Pythagoras theorem, hypotenuse square is equal to height square plus base square. So if L is the hypotenuse, then L is equal to square root of h square plus b square. And area can be calculated half into base into height, that is half bh, where b is the base and h is the height. Perimeter is equal to sum of all these lengths, that is L plus b plus h. Equilateral triangle. For an equilateral triangle, all the 3 sides will be equal. So, for calculating the area, we have to use root 3 divided by 4 into side square. That is root 3 by 4 a square here. Perimeter is equal to 3 times of the side. And h can be calculated by root 3 divided by 2 into side. For an isosceles triangle, the 2 sides will be always equal. So, perimeter can be calculated 2 into A is the equal side plus base B. So, perimeter is equal to 2A plus B and H can be calculated by taking square root of A square minus, that is equal side square minus base square divided by 4. And area can be calculated by B by 2 into square root of A square minus B square by 4. For an irregular triangle, all the 3 sides measurements will be different. So, perimeter will be A plus B plus C, provided A, B, C are the sides of the triangle. So, area is equal to square root of S into S minus A into S minus B into S minus C, where S is equal to all the sides sum divided by 2. Next is trapezium. For a trapezium, the sides are different. So, we have two parallel sides A and B. So we will add this A plus B and then multiply with the height of the trapezium and divide it by 2. So area is equal to half of height into sum of the parallel sides. That is half h into A plus B. Perimeter is equal to A plus B plus C plus D. Now we will check how to calculate 3D shapes. Cuboid. Cuboid is a three-dimensional geometrical shape. The sides are base B, length L and height h. Therefore, volume we can calculate by length into breadth into height. That is LBH, and total surface area will be 2 times L into B plus B into H plus L into H. Next is cylinder. For a cylinder, we know the top and bottom there are circles. For a circle, we already learned the area of the circle is pi r square, and height of the cylinder is, if the height of the cylinder is h, then volume is equal to pi r square h or pi d square by 4 into h. That is base area into height is the volume. Curved surface area is equal to 2 pi r h, and total surface area is 2 pi r into r plus h. Hollow cylinder or pipe. We can see two cylinders here. Radius of external cylinder is denoted by capital R and the radius of inner cylinder is denoted by small letter r. We will use formula of total surface area as 2 pi h into capital R plus small r plus 2 pi into capital R square minus small r square, and volume is equal to pi into capital R square minus r square small letter r square into h. Cone. For the cone, volume is equal to 1/3 of pi r square h. We already know pi r square h is the volume of a cylinder. So, cone we will take 1/3 of that cylinder, that is 1/3 pi r square h. Curved surface area of a cone is pi r into L, which L is the slanting length of the cone. Total surface area is equal to curved surface area plus bottom circular area. So pi rl plus pi r square, we can write it as pi r into L plus r. Next is square column or square beam. Here the sides are, we know, A and height as h. If we calculate the volume, which will be equal to A square into h, that is the top surface area or bottom surface area will be A into A square into height, surface area into height of the column or beam. And lateral surface area is equal to 4 times A into h, and total surface area will be 4AH plus 2A square. For a cube, all the 3 sides, that is length, breadth and height, will be same. So volume is equal to A cube, provided the sides are A centimeter or A meter. Surface area is equal to 6A square. Sphere. A sphere is a perfectly round and symmetrical in all directions. For a sphere of radius r, volume is equal to 4/3 into pi r cube, and total surface area will be equal to 4 pi r square. Hemisphere. Hemisphere is half of the sphere. If r is the radius of the sphere, hemisphere, then volume is equal to 2 by 3 pi r cube and curved surface area is equal to 2 pi r square. Total surface area is equal to 3 pi r square. Frustum. A frustum is a three-dimensional geometrical shape that resembles a cone, but its top portion sliced off by a plane parallel to the base. As a result, a frustum has two parallel circular bases of different sizes connected by a curved surface. It is also referred as truncated cone. The volume of the frustum is equal to 1/3 pi h into capital R square plus r into small r. Lateral surface area is equal to pi into capital R plus small r into L, where r is the base radius and small r is the top radius and L is the slant height. Total surface area is equal to pi into r plus r into L plus pi into capital R square plus small r square.